So for each one, you're going to go stat, regression, over to simple linear. Okay. And then let's go x1 and y1 first. Whoops. And that's all you need if you want the correlation coefficient. So there it is, R, and that's in that first kind of big block of output you're given in the top of the output, R, and it tells you there's the correlation coefficient, negative 0.816. And then was it something beyond that that's, did you have questions about, Colonel? Okay. And then you can actually at this point go to options and edit and then choose the other, two more data sets and so on and so forth. So that's all it's asking there is for that correlation coefficient. Anyone else have a question? Homework question this morning?
So what do you go to again?
Sorry?
Yeah, what do you go to again for this?
You can either shut this down and go get the regression again, or if you click the little box where it says options up in the upper left, and it says edit, so you can go back in and edit that, what I want to say, that command box. And then you can just switch the X's and Y's and get your next R value, so on and so forth. Okay? Everybody's good? Yeah, okay, cool. Again, after this section, this chapter, we kind of pick up again on our from our summary stats and kind of continue. And all of that will kind of accumulate through the rest of the semester. Okay. But, getting that summary stats down is important. Okay, so last time, we were working through the entire process of setting up a linear correlation problem, working through all the steps. So does someone have what part we were on? We
finished on
some of those residuals. Okay. Thank you. So sorry, I'm a little scattered this morning. I don't know why. Just apologize. I guess am I allowed to have a scattered day? Thank you. No, you're not. So we were working on the data set for 126. Okay, for 126. For 126. Okay, so we were covering the entire chapter with this one problem. We looked at the scatter plot. We decided there was a good, nice linear pattern going on. And this data is someone's credit score, their FICO credit score, and the interest rate that they would be able to get on some kind of loan. We looked at the scatter plot, the linear pattern looked really good. We calculated and interpreted the R value. We found the equation of the regression line. We interpreted we interpreted the slope. We decided that the y-intercept had no meaning in this case. We did a couple predictions using the regression line. We found the individual residuals, right? You guys with me? You remember all this? Okay. We also found the overall error, which is the sum of the squared residuals. And what are those residuals? Let's review that. Can someone? What is a residual?
Correlation. Coefficient? Yeah, no.
No, we're two different things. A residual is sometimes denoted with an R though, so yeah, that can be a little tough to remember to separate out. Anybody?
The residual
Yeah, Kevin.
is the distance from it's a plot, your actual plot. The distance from the predicted line it should be on is the residual.
Good, yes, that's right, that's right. That's right. A residual is the vertical distance between each data value and the regression line. Good. Yeah, that's exactly what it is. And it's error. So for that particular value of x, each ordered pair is going to have a residual. Residual may be 0 if the line goes right exactly through that point. But it's the error in predicting at that x value. Residuals are okay, and we expect them to occur. Remember, the farther away the points are from the regression line, the bigger your overall residuals are going to be. That sum of squared residuals. The closer they are to that line, the smaller that sum is going to be. Okay. The better the R value means what about the residuals? Let's say you've got a really good R value. What does it tell you about the relationship of the points to the line? They're very close. Yeah, good. They're very close. Exactly. So the sum of the squared residuals is the overall error. Okay. So that's where we left off. All right. Now remember, we also talked about the fact that when we gather this data, we have observed data in a certain realm. And we don't go outside of that realm to make predictions because we don't know what happens out there. We won't extrapolate outside of our observed data. Okay? So, I'm going to bring up the regression on this data set again, and I want to talk about the coefficient of determination. Let's see, regressions. Okay, we're using credit score to predict interest rate. And right now I'm just going to go compute. And I want to take a look again at the regression line and the points. Okay. I also want okay, so the mean interest rate here is 11.6. I just found that with the summary statistics. Okay, so let's talk about that with respect to the errors and the line and all this happy stuff. Okay. If we want to predict interest rate, we could have just gathered all of the let me rephrase. We could have just gathered data of all the interest rates. And we would find that the average interest rate is 11.6. That would be, I don't know, what do you think? Maybe right there? Here's 10, here's 15, something like that. Doesn't have to be perfect. Okay. Okay, so let's say that that the only thing that we've collected are these interest rates. And we would say, what's the average interest rate? What interest rate can I get? Well, on average, you can get 11.6. Well, bless you.
Thank you.
We want to do better than to tell someone, okay, on average, you can get 11.6. We want to be more accurate in being able to predict what kind of interest rate they can get. So instead of just collecting data on interest rate, we go out and we collect not only the person's interest rate, but their credit score. And we ask, could I more accurately predict their interest rate if I also know their credit score? Okay? Now if, bless you, if we had just collected interest rates, okay, these would be our errors. The errors would be the distance to the mean. So this would be our overall error. Some of them are a little wobbly there, but they're supposed to be lines. So that would be our overall error if we're just using the mean interest rate. But again, we say, well, we want to do better than just using the average. So instead of just gathering interest rates, we gather these ordered pairs, including the person's credit score. So now,
Thank you.
the error goes from being the total of these blue lines, right, distances, to the sum of those black lines. Okay? So the coefficient of determination tells us the percentage of this total blue distance that we're able to eliminate by bringing credit score in and predicting interest rate also using credit score as opposed to just the average interest rate. So it's the percentage of this overall error that we're able to get rid of. Does that make sense? How much, percentage-wise, how much has the error been reduced by bringing credit score into the mix? Does that make sense? You guys with me? Kind of, sort of? Okay. The coefficient of determination
Oh,
bless
God.
you, is given by R
Sorry,
squared.
guys.
In StatCrunch, it's a capital R. In generally, it's a lowercase r. But again, it's the percentage of error eliminated by bringing or using another variable, which in this case is the x, to predict y. Instead, STEAD, is that right? Only using y bar, the average of y. I forget how they put it in your book, but it's not as specific. Bless you. It can also be thought of as how well the regression line describes the relationship between x and y variables. That's kind of generic, whatever. But specifically, that's what it does. It indeed is, so we talked about in 4.1 the value of r, which is the linear correlation coefficient. This is indeed the square of r. So if you had r took the square, or squared it, you would get coefficient of determination. If you took the square root of the coefficient of determination, you would end up with plus or minus r. Okay, the correlation, the coefficient of determination, so it's always a number between 0 and 1. Again, because it's a percentage. It's a percentage. Does this kind of make sense? If you think about it just in terms of distance? Does it kind of make sense? You guys don't look like you're too keen on this. Are you kind of, thumbs up? Kind of, okay. Just need a few examples, maybe? Okay. In this case, the case of the FICO scores, okay? If you go back to that output that we generated, the r squared is right under the r value, and it's at 0.95 in this case. And that means that 95% of that blue distance was eliminated by bringing in the credit score to predict interest rate instead of just using the mean interest rate. Okay, let's write that. R squared of 0.95 means that 95% of the error in predicting interest rate has been eliminated. It's like we're doing 95% better than we would if we just reported the average interest rate. Okay. Has been eliminated by using credit score. Which is our x. Instead of just the mean interest rate, or y bar. So that's one of our last one of our last calculations or steps that we're going to want to look at. The last of which we talked about just briefly last time, which was the residual plot. So there could be some underlying stuff here happening here that would make the pairing of these variables seem like a good match, but there may be some underlying stuff that we would need to be concerned about. So the residual plot will give us another indication of how well we've done pairing up these two variables. Remember, the SS error is your sum of squared residuals, okay? Slope and intercept, coefficient of determination, correlation coefficient. So you've got a lot of good stuff there. And a lot of other stuff that we don't need. That would be your next class. Okay, so residual plot, if you want to go back into options and edit, a residual plot, you would go down to where it says graphs and scroll down where it says residuals versus x values. And compute. It's going to give us our output back, but the arrow at the bottom of the output will take us over to the residual plot. And I think, did we look at this residual plot last time? Or was it a different one?
Where do we go?
It was a different one? Thank you. In your regression output, you go down to where it says graphs, and then you go residuals versus x values specifically. And then you'll get that graph if you click the little blue arrow at the bottom. So, okay, we want to see, as opposed, kind of interesting because with the scatter plot, we want to see a linear trend, right? We want to see those data values pretty much line up. But in a residual plot, we want to see no pattern whatsoever. And, you know, you want to just see a random scatter, which it looks like we got. So it's just another indication that pairing up these two variables together was a good idea. Works okay. Okay. So those are the last couple of things we would want to talk about. What number was the sum of the squared residuals?
6.
Number 6? 6? Yeah? So all the steps last time, I had them all numbered.
Oh, yeah, we went to 6.
6?
So
Okay.
this one would be 7, right?
So the coefficient of determination, let's do 7, and then 8 would be the residual plot. And we want that to be no pattern. No pattern is a good thing. We went through several steps with the bare data. We found the regression line, we did some predictions, we interpreted the slope, we found the sum of the squared residuals. Let's go back to the bare data and look at the R squared value and did we look at the residual plot for the bare data? Was that the one we looked at, Melissa? Maybe we can find another set of data to look at the residual plot. Oh, you know what? Let's use the data, the commute time. This was 4/1/25. So we also looked at this problem to see if we could find a relationship between someone's commute time and some kind of a measurable well-being score, they call it. Okay, so let's take a look at the R squared value. So we're gonna calculate a linear regression. I don't know about you guys, but I've done all this stuff by hand, and I can tell you it is no fun whatsoever. So I'm pretty darn happy that we have StackCrunch. So we've got the, this is data set 4/1/25. The commute score versus, for the commute time versus the well-being score. I'm going to, oh, you know what, let's do this. Let's do this. We're gonna do all kinds of stuff here. So we're gonna select commute time as our X variable, the well-being index composite score as the Y variable. We're gonna go down, we're gonna do a few predictions. After a prediction of Y, let's see, our commute time is anywhere between 5 and 105 minutes. Somebody give me a number between there. It doesn't have to be one that we've observed. 35? Okay. Well, 35 is already there. How about a different one?
45.
45? Okay, let's say somebody's commute time is 45 minutes. It can be a value that's already in the data set, but it can be anything between 5 and 105 minutes. Okay, then I'm going to go down where it says save. I'm going to save the residuals. And where it says graphs, I'm going to save, if you go up to the top and click on fitted line plot, and then you hold your finger on your control button, scroll down and hit residuals versus X values, it'll give you both of those plots. Okay, so we're going to get all kinds of stuff here. Are you guys with me? Okay. We've got our scatter plot with our fitted line. Scatter plot looks really good, as we had already looked at. Here's our data. Our R value was negative 0.98. So that tells us there's a very strong at 0.98, negative 0.98, right? Negative linear relationship between commute time and well-being score. Our regression line, so I'm just going to fly through this real fast, is, and I think we did this, didn't we? Yeah. Negative 0.048. X plus 69. Okay, for a commute time of 45 minutes, down at the bottom, we should have, we look at about 66.9 on the well-being score.
What is that you're writing down right now?
When the commute time is 45 minutes, we predict this person's well-being score, and you know, whatever this means, the psychologist or whoever, about 66.9. You could also round it to the nearest, 67. And we can say we predict that the well-being score would be 69. Okay, our R-squared value, 0.96. So again, the closer that the points are to the line, the R-squared value is also going to be larger. Okay, remember it's a percentage, so it's always going to be positive. So an R-squared of 0.96 means that 96% of the error in predicting well-being score, has been eliminated by using commute time as our x values, instead of the average well-being score. And that would be y bar. Residual, here's all of our residuals, generated those as well. The residual for the data value 50 and 66.4. How did I get the residuals? So if you go back to options, edit, scroll down where it says save residuals. Yeah, so you should have them if you move your output. Yeah, you should have them, just take the corner, drag that, make it smaller. That thing needs to go, it can go away. Yeah. So if you make that smaller. Yeah, there they are. Yeah, so they pop into the spreadsheet. Okay, so the residual for the data value, let's say 50 and 66.4. Is, looks like negative 0.234. It's negative. Is that an under or over approximation? You got a 50-50 here, right? It's actually an over approximation. Remember, when the residual is negative, it means the data value is below the line. So when the line is above, it's an over approximation. Okay, the sum of the squared residuals. SS error, 0.677. Wow, that's really small. if you click, if you generated both of those graphs, you click the bottom blue arrows twice, you have your residual plot.
Isn't the residual square, is it, I think it's, 0.677, right?
Was it 667 or 677?
677.
677? Thank you. Okay. So, do you see any pattern there with the residuals? Which is good, that's what we want. You with me?
Wait, I didn't get that.
If you,
Oh, there's 3, never mind, my bad. I didn't know if it was an extra click.
okay. Yeah, just 2 graphs over. Okay, so, let's see, I think that's about it. And let's look at one more residual plot. Wait, we looked at the bear, we looked at the credit score, and we looked at the commute time, right? Yeah, we're good. You guys know how to find one, and, okay. I think we pretty much, nailed it. Okay, worksheet?